Everybody, it's Miss Phoebus, and this is lesson 43, trajectory problems. And you may be like, what is that? Trajectory is one of our vocabulary words, so let's look at it. It's the path followed by a projectile flying or an object moving under the action of given forces. And our given forces are probably going to be gravity today. Now, these are not the only style problems that you can have that you work with quadratics in, but these are some of the most popular. So nobody's going to walk up to you and go, hey, what's the vertex of this quadratic? But they may walk up to you and go, hey, I've got this object flying through the air and I really need to know how high it's going to go. Or, hey, I've got to launch this thing and it's going to go up and then it's going to come down and I need to know where it comes down. So that's where your application of your quadratics are going to come in, is it's going to help you be able to work with some real world problems. So we're working with word problems today. So our skill that we're using, learning, I can use quadratic models to answer questions in a real world context involving trajectory, area, key characteristics of the function, models, different situations. So we are on page 189 in the notes. On page 189, you have this wonderful picture of all kinds of stuff going on. We have a soccer ball. We have a model rocket being launched. We are going to have lots of things probably flying through the air, but that's not the only type. We might have business models. We might have just some different things that are modeled by a quadratic. And so we have to figure out certain things based off of the wording of the problem. What do they want from you? Okay, so the x-axis is going to represent time, almost always. If it's not going to represent time, they're going to tell you what it does represent, and they will spell it out for you by telling you what your variable is and what does it mean. The y-axis is usually height above the ground, especially if we are dealing with, we're kicking something into the air, we're launching something, we're dealing with height. Now, if it's not going to represent height, again, they're going to tell you what f of x or what y equals. We still have an axis of symmetry. That axis of symmetry does go through the vertex, which is the highest point. And so a lot of times what the question will be is, hey, I'm going to kick this soccer ball and this is what I know about it. This is how hard I'm kicking. This is how high, I am when I kick the ball or how far the ball is above the ground. I want to know when it hits its maximum height. And that's just a vertex problem. So the x value of that vertex would be the time that it takes to reach the maximum height. The y value of that vertex would be the actual maximum height. So most of the time when a vertex is kind of being given as an answer, it's actually answering two questions. How high does it go? That's the y part of the vertex. And then how long does it take to get there? That's the x part of the vertex. All right, we do have a y-intercept, and that's when, in this case, when time is 0. So it is the starting height of my object from, I might be launching my model rocket off the top of a building or on a hill or something like that. I'm kicking a ball and I'm on a hill and it's going to hit the ground somewhere else that's not on a hill. So my y-intercept is my starting height of my object. Now, in this case, and it's not always the case, but in this case, I have a -0. See, I was on the left part of that x-axis, and I have a +0 on the right part of the x-axis. Sometimes I can have two positive zeros. Sometimes it can be at 0, 0. Okay, but when I'm looking at these zeros, I'm looking at when my object is on the ground. So the time that the object hits the ground or the time that it starts on the ground or something like that. Now when it's at 0, 0, it's on the ground at the start. If it's a -0, We're not using that in real world situations. That means that it started above the ground, and then if I was going to backtrack, like go back in time, when would it be on the ground? That's not going to be applicable here. So if I'm like, hey, when's it hit the ground? And I've got positive 3 seconds and negative 1.5 seconds, the negative gets thrown out because that doesn't count. That's like a back in time. All right, so these are all the parts of the quadratic that we've already talked about. We've talked about the vertex along with the axis of symmetry. We've talked about the y-intercept. We've talked about zeros. And so now we're pulling those pieces from abstract algebra land into real world. Guys, we're going to be doing some physics. Isn't that exciting? Physics. So physics is just applied math. That's all that it is. Okay, so we're going to be looking at the behavior of things as they move through the physical world. That's physics. That's all it is, physics. All right, so here I have some keywords for you. I already got one of them there for you. So if they're asking you the questions, how long, and you have this table, by the way, you should be filling it out. How long until it reaches its maximum height, or what is its maximum height? Then that means that they are asking for you to find the vertex, which is a maximum. Because we're kicking something up into the air and then it's going to come back down. So that means my parabola is opening down. My vertex is the highest point of maximum. So how long will be answered by negative b over 2a. The max height will be the y part of the vertex. You find that by taking the x part, plugging it back in. So you know how to find a vertex. You do. I promise you do. Negative b over 2a. We've been doing it. Now in the graphing calculator, there is a way to find the vertex, and these are the buttons that you hit. So if you want to do it on the graphing calculator, you hit, once you have your equation in the calculator in y equals, you hit second trace 4, and then you have to be left of the vertex and hit enter, go right past the vertex, hit enter, and then hit enter one more time, and it will tell you what the vertex is. Sometimes it's not going to be nice. So if you notice that big blue box there at the bottom, decimals are okay for these kinds of problems because 11/4 seconds doesn't mean anything to us. But 2 3/4, 2.75 seconds, that means, oh, it's almost 3 seconds. That means something to us. So in all of your trajectory problems, decimals are okay. So that means, and later on we're going to talk about running the quadratic formula, that means decimals are okay. But it has to be a real world problem. If it's just an algebra problem, like we've been doing all the way up until this point, decimals are not okay. So I want you to understand a decimal answer is a fine answer, but only if it is coming from a real world problem. You're launching a model rocket, you're launching a regular rocket, you're kicking a soccer ball, somebody else is jumping off a diving board. Decimals are okay there. However, 3x squared minus 5x plus 2, tell me the zeros. I want exact solutions. I want those exact solutions, seeing the square root, the radical, all that stuff being broken down properly, okay? So this is a little bit different, but we're still using those concepts that we've already learned. And it's a good little bit of a review. All right, now, if the questions are, how long is it in the air? How long until it hits the ground? So those are times, those are x values. They're asking for zeros. You could factor them. You could graph them. I highly recommending the quadratic formula because remember, not everything is factorable. Graphing, you might not even be able to see it. What if the numbers are so big you like go to plot it in the graphing calculator and you can't even see it because the parabola is so big? But the quadratic formula will give you a right answer every time. So that's going to be the thing that I suggest you to do. On the graphing calculator, you can do the zero function. You can, and we talked about this earlier, in the unit, you can hit second trace and choose 2 and go left and right and hit enter. And then if they're not very nice, it's going to be giving you a decimal, but then that's okay. So that's another option for you, like if you want to use the graphing calculator. Quadratic formula will work every time. All right, the last situation that you might be in, and we're not going to spend too much time on this because it's pretty straightforward, is what is the height of the object after so many seconds? So like we kick a soccer ball into the air. What's its height after 1 second? All you got to do is plug 1 in for x. So what they're asking is for you to take whatever the time is, plug it in for x, and get the y value. Just like you would with the vertex. Remember, finding the maximum height, you plug in that x value, that negative b over 2a. So this is a different time, not the vertex, but a different time. You just plug it in. So that is something that can happen. But we're not going to spend a whole lot of time on that just because it's pretty straightforward. You plug it in, you go, okay? So we're going to spend more time on the quadratic formula piece and the vertex piece. And so if you wanted to do this on the graphing calculator, you can hit, you have to have your equation in y equals second trace 1. All right, so here we go. The main problem that students have is they don't know, is it a vertex problem or a zeros problem? Vertex problem, you're looking for keywords, maximum, minimum, can even pop up. Remember I said it's not always trajectory. We might have business problems, and they might say, we want the minimum cost or something like that. So maximum or minimum, we see those words, we choose vertex. If it's about when does it hit the ground or when does it reach a specific height, that is a zeros problem. We use the quadratic formula. So, ladies and gentlemen, you have to read. You can't just guess and go, this feels like a vertex problem. I'm going to do the vertex, because you got a 50-50 shot of being wrong. We want to be right. So we're going to read. We're going to read for key words, and then those key words are going to dictate how we solve this problem. So fireworks, the equation h of t, and remember h of t, f of x, anything like that, that just means y, is negative 16t squared plus 88t plus 610. And it gives the height of the star, the thing that, the firework, h of t, so h of t is the height in feet, so they give you units, at time t, so t, where we usually have x's, we now have t's, t stands for time, and time is measured in seconds. So they will give you units, they will most of the time explain the variables so you have an idea of what this is about. Now in the future, you may have to write the equation, not in my class. I know in pre-cal, when I teach pre-cal, we write the equations ourselves. And there's a way to do that. You will be given the equation every single time. It's can you figure out from the rest of the problem, from the questions, what they want from us. So how long will it take for the star to reach its maximum height? I want you to grab a highlighter or just underline it or something. Maximum is our key word here. Maximum height. So let's think about this. We've got somebody shooting off fireworks. They're going to go up. They're going to explode and do fireworky things, and then who cares about the rest of it, right? It's over. There's some sort of garbage that, ashes and embers and stuff like that fall down. But we want to know the max height. So if we pretend, there's the rest of my vertex, let's say it does fall down, we want to know how high it is above the ground. This piece right here, that's the vertex. So on your homework, it asks you, part of the question is for you to identify, is it a vertex problem or is it a zeros problem? In this case, it is a vertex problem. Now, if I circle vertex and it is a vertex problem and then I run the quadratic formula, wrong. Okay? I'm identifying from my reading that it's a vertex problem. This piece is also going to be the part B. How far above the ground will it be? That's the height. So that's how tall it is. So my X piece of my vertex, remember X comma Y is our vertex. The first thing that I'm going to get is time. It's going to answer the how long part. Comma, the height above the ground. The Y value is how high it goes. Okay, so the second part, how high it goes, would be how far above the ground it will be. So both pieces, the x and the y components of my vertex, will answer this problem. So the question is, how do you find a vertex? So x equals negative b over 2a. And we've got it all set up here. My negative 16, that's my A. 88, that's my B. And then 610, that's my C. So I'm going to plug this in. I'm going to get negative 88 over 2 times negative 16. Now, the thing is that we are allowed to have decimals now. So you could give me a fraction as an answer, but it might not make sense as far as time goes. So let's break out the calculator, and we're going to just stick that in the calculator. Negative 88 divided by 2 times negative 16. Okay, so I've got my 2 times negative 16 in the denominator, and then I hit enter, and I get 2.75. Now, if I get a negative answer, that means it happened back in time. So a negative answer going back in time should mean, oh, something's not right. I might want to look at that again. Okay, so 2.75 seconds. That is how long it was in the air. And units, seconds in this case, I want those units there so I can know what you're talking about. You can even call this, if you would rather, call this t, because that's our variable. T equals, I'm okay with you calling it x though, because that is our little formula that we've been working on. So that answers the how long will it take for it to reach the maximum height. How do you find the y part of the vertex? You plug that back in. So we're going to take that 2.75 seconds, we're going to plug it back in. Now here is the most missed piece right here. People forget to square that first one. Or they square both of them. You can't square both of them. You square the first one, then you don't square the second one, and then guess what? You shove it in a calculator. So let's do that. We're going to shove it in a calculator. So, move this over here. We're going to have negative 16 times 2.75 squared plus 88 times 2.75 plus 610. Let's make sure I typed it in correctly. Looks good. All right, enter. 731. So that's my y value, or my h of t value, which is height in feet. So you can write y, or you can write h of t, 731 feet above the ground. So if you want to write it as a point, you can. You have to write that one first, this one second. But you're answering two questions with two different values, but it's finding the vertex. Okay? The key words are either maximum or minimum. Now, for some reason, this is hard, and I don't know why. I really, really don't know why it's hard for students, because it's either doing one thing. It's either starting here, going up, coming down. You're either being asked about this thing, how high did it go, or when did it hit the ground, or when did it hit a specific height. That's it. So you need to visualize, or you need to draw a picture and try to figure out what is going on in that picture, in that wording of that situation. So here we go. A ball is thrown upwards from the top of a 240-foot building with an initial velocity of 32 feet per second. The height of the ball, h, after t seconds is modeled by the equation h of t equals negative 16t squared plus 32t plus 240. When does the ball hit the ground? So the first two sentences, with the exception of the equation, are just information that you don't necessarily need, but you can see where these numbers came from. Here's 240, here's 240. Here's 32 feet per second, here's 32 feet per second. And this negative 16 keeps popping up because that is the pull of gravity, right? You are at the top of a building. You are throwing a ball up it's going to have to come down and hit the ground because the pull of gravity is so strong. You can't just stay up there in the sky for the rest of its days. It's not going to work. So the beginning pieces of this are to kind of set the stage for you what's going on if you had to write the equation. You don't have to. So sometimes it's a little bit extra information, but it's not like incorrect information. Like they're going to send you down a wrong path. Okay, so the question is, when does the ball hit the ground? So my question for you is this a vertex problem or a zeros problem? Vertex would say maximum or minimum. Zeros, quadratic formula, is going to be when does it hit the ground or when does it hit a specific height. This is wanting to know when does it hit the ground. So this is a zeros problem. Okay, so that means for the quadratic formula, I have to look at this equaling a height of 0. That's the height when it's on the ground, right? Ball's on the ground, it's got a height of 0 above the ground because it's on the ground. Now, that's not always a 0. What if they wanted to know when is the ball 50 feet above the ground? Or when is the ball 10 feet above the ground? Then we would change this number. But because it's 0, and I always want my quadratic formula to equal, or when I do the quadratic formula, I want it to equal 0, I'm ready for the quadratic formula. A equals -16, B equals 32, and C equals 240. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Are you learning it? All right, so -b is going to be a -32 plus or minus the square root of 32 squared minus 4 times a is -16 times c is 240. All over 2 times -16. Now, you're going to work this out, and you are going to remember that decimals are okay. They're okay here. So we're going to, you not only can put the stuff underneath the radical in, you could go ahead and put the whole radical in. So let me work with this. So I'm gonna be using my calculator off screen. -32 plus or minus, I'm just gonna go ahead and not put the square root in. I'm going to just type all of that in my calculator. So the square root of 32 squared, and you got to make sure you wrap it in parentheses, minus 4 times -16 times 240. I get 128, even with the square root in there, so it was a perfect square. All over 2 times -16 is -32. Now I have to do the plus and then the minus, just like I did with the regular algebra piece. And I'm going to get 2 answers. So I've got -32 plus 128, enter in my calculator, divide by -32, and I get -3. And then I have -32 minus 128, enter, divide by -32. So I have to do like this piece and then hit enter and then divide. Or you would have to wrap that in parentheses if you want to put it in at the same time. So I get 5. So the ball hits the ground in -3 seconds and in 5 seconds. So what we talked about earlier was that the -0 gets thrown out because the -0 is what happens. Like, where was the ball if I complete that parabola? And this is not being launched from the top of the building. This is going through the building. It's craziness. We are not doing that. So we throw out the negative answer. No good. And we keep the positive one. We throw some seconds on it, and we found our answer. Okay? So you have to make sure you are being very careful about how you're plugging things in. I have people that are still not putting the whole entire, like remember how we were practicing and putting this in, just that? And there are people that are not even using the calculator on that in the in-class people. And I don't know how to help them other than say, use your calculator, okay? And especially since we're getting, in this case, we didn't get any decimals because the problem was nice, but in the future, we're gonna get decimals. And you're not gonna want to be plugging stuff in the calculator and it be wrong. We want to get practice on getting that right. So make sure you're wrapping pieces in parentheses, you're pulling the right things for A, B, and C, okay? Make sure you're chunking it into the calculator appropriately. You're doing the negative 32 plus 128, hit enter, then divide by negative 32, okay? So make sure that you are understanding that this quadratic is telling us when the ball is hitting the ground, okay? And negative answers do not work. Let's look at another one. A diver jumps from a platform of 10 meters above the surface of the water. What is the height of the diver given by the equation h of t equals negative 4.9 t squared plus 3.5 t plus 10? Now notice negative 16 isn't in front of my t squared. That's because this is in meters. So when we look at the pull of gravity, we look at it as that negative 16 is in feet per second squared, and this is 4.9 meters per second squared. So we changed units, that's why it's not a 16 anymore. All right, for what time is the diver's height 1 meter? Okay, so let's get a picture going so that we can understand. So here is our platform that our diver is going to dive off of. Isn't that beautiful? They're going into a pool, so let's give them some water. Okay, and so they are going to jump off and they're going to come down here and they're going to hit the water and hopefully do a great maneuver and it's going to be wonderful. Okay, so the question is, for what time is a diver's height 1 meter above the water? So like we want to know when they reach like this height. So it's almost like a 0, but we have to shift the water level. Okay, so what we're going to do is we're going to take our equation and we are going to set it equal to 1. So here is the equation of the diver, and what it's doing equals, we want to know when its height equals 1 meter above the water. Okay, now the question is, can we learn the quadratic formula like this? Because that's what we're doing. We're doing a zeros problem. They said nothing about what's the highest point that this diver is going to reach. So it has to be a zeros problem. So in order to run the quadratic formula, the whole entire thing has to equal 0. If it doesn't equal 0, I can't run the quadratic formula. So negative 4.9 t squared plus 3.5 t plus 9 equals 0. Now it's ready to go. But I had to change the equation because I'm not interested in when is the diver going to hit the water. When is the diver going to be at 1 meter above the water? So I have to change the equation a little bit. All right. Our A value is negative 4.9. Our B value is 3.5. And our C value is now 9. If I don't change that height from being equals 0 to a being equals 1, I'm going to get the wrong answer. I'm going to get a time when the diver hits the ground. No, divers are not hitting the ground. Divers are hitting water when the diver hits the water. Okay, so you have to make that change if they give you a specific height. Okay, all right, here we go. Quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, our b value is 3.5, so negative 3.5 plus or minus the square root of 3.5 squared minus 4 times negative 4.9 times 9, all over 2 times negative 4.9. So I'm going to start, remember decimals are okay here, but only on real world problems. I'm going to start with my square root. So I'm going to come up here, I'm going to have negative 3.5 plus or minus something all over, was that negative 9.1? So negative 3.5 squared, actually it's 3.5 squared, sorry. 3.5 squared minus 4 times negative 4.9 times 9, and that's all under a square root, and I get 13.73. All right, and then I'm going to do the adding and subtracting. Now, I'm going to go ahead and share a secret with you. We're dividing by a negative number. So if I end up with a positive number divided by a negative number, my answer is always going to be negative, right? So I want it to always be negative on top. And that right there, negative 3.5 minus 13.73, that's going to be negative. So then when I divide it by a negative, I get a positive. So let's stick it in the calculator. Negative 3.5 minus 13.73 divided by negative 9.1, and that is, that's not right, that's 9.8, sorry, 9.8 divided by negative 9.8. All right, that is 1.76. 1.76 seconds for the diver to hit a height of 1 meter. Now, if I do the negative 3.5 plus 13.73 and then divide that by negative 9.8, I get a negative 1.044 seconds. And that would be, like over here, when is the diver hitting? But that's back in time, right? So we do not keep the negative piece. We throw it out. We only want the positive one, because that's the only one that makes sense. Going back in time through the diving board and down to 1 meter, that's not going to make sense for our situation. So you are not guaranteed that there's one negative, one positive. You probably should still explore it a little bit. But if you can kind of look at the top and notice, oh, if I do that, I'm going to get a positive, and a positive divided by a negative, you know, can kind of cut down your work a little bit. But you could have 2 positive zeros. It is possible. All right, a baseball is thrown into the air with an upward velocity of 30 feet per second. Its height, h, in feet after t seconds is given by the function h of t equals negative 16 t squared plus 30t plus 6. So we've got an equation. How long will it take the ball to height? I think I'm missing some words. How long will it take the ball to reach its maximum height? Okay? And then what is the maximum height that the ball reaches? Okay, so I'm going to give you a second. I need you to think about the situation. Is this a vertex problem or a zeros problem? All right, so we have a ball reaching a maximum height. Maximum is a vertex. This is a vertex problem. So let's run the vertex. How do you find the vertex? X equals negative b over 2a. Our b value is 30, so this is negative 30 over 2 times negative 16. Let's stick that in the calculator. So that's what, negative 30 over negative 32, which is 9.9375, and that is time in seconds. That's the first part. Because it says maximum, I run vertex. And that's the first part of finding the vertex. All right, let's find the second part of the vertex, and we do that by plugging in 0.9375. Now, some people are like, can I just plug in 0.9? Can I just plug in 0.94? And I'm like, I guess you can, but the more you round something, the further away from the correct answer that you will be. So you want to be very cautious in rounding. You want precision. The more decimal places, the better. And these are all the decimal places that we have. So why not stick them on the calculator? You got to hit a few more buttons. You're going to live. I promise. Okay. Make sure you take that negative 16 times 0.9375. Make sure you square that. If you forget the squared, you're going to end up not looking with the right answer. Not looking good. All right. I shoved it all in the calculator, and I get 20.0625. So if you want to write 20.06, I would give some decimals to indicate it's not 20 exactly. Now it's a max height, and look right here, height is in feet. So I'm going to be looking for units. You better be showing me units, okay? Because then that makes sense to me. If you give me a number and then seconds, I go, oh, that means time. You give me a number in feet. Oh, that means they're saying that this is the height. So you're telling me what those values are by using your units, okay? Let's look at another one. The height of a golf ball in feet as it travels through the air is modeled by the equation h of t equals negative 16t squared plus 100t. Now this one's missing a constant, but that's okay. Where t is time in seconds after the ball was hit. When will the ball hit the ground? So I'm going to give you a second. Is this a vertex problem or a zeros problem? This is a zeros problem, and the reason why I know it's zero is it says, when does the ball hit the ground? Now, this is one where you can do something other than the quadratic formula. So let me show you that, but then we will run the quadratic formula as well. For these two pieces, I can factor out a greatest common factor. I'm going to say 4t. And you could even pull out a negative 4t. And then get 4t minus 25. And if you have it hitting the ground equaling 0, then you can just set each part equal to 0. And then solve for time. Minus 25 equals 0. So 4t equals 25. So t equals 25 over 4, which is, what, 6 1/4? 6.25? Yep, 6.25. Okay, so that's a different way to do it. Remember I said you could factor, you could graph, or you could run the quadratic formula. Quadratic formula always works. This is that option where, you have something different. Let's look at the quadratic formula though. So A is negative 16. B is 100, C is 0. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative 100 plus or minus the square root of 100 squared, forgot my parentheses, minus 4 times negative 16 times 0. Now I love it when that happens, because when c is 0, because that wipes out a lot of stuff. That wipes out this piece, right? Negative 4 times negative 16 times 0 is 0. And that means I'm looking at the square root of 100 squared. Well, we know that the squared and the square root will cancel each other out. That means I've got negative 100 plus or minus 100 all over negative 32. Negative 100 plus 100 is 0. 0 divided by negative 32 is 0. So that's where this comes from. So I'm still getting 0. And then look at negative 100 minus 100 over negative 32. If we stick that in the calculator, that's what, negative 200 divided by negative 32, which I get 6.25. I get 2 answers. Now, the question is, which one is the right answer? Which one should we choose? Because we have 2 answers. So we choose the 6.25. okay? Because the 0 is really 0, 0. This is the starting. This is the starting value, okay? So it was on the ground when it started. Does that answer when will the ball hit the ground? It does not. So we throw out the 0 component and we look at the 6.25 seconds as being our answer. So we got it two different ways. The one on the left, the factoring was pretty nice, but that's not the only way to do it. If you are like dead set on, okay, when it hits the ground, I only want to have one thing to go to, quadratic formula, all the way, baby. Okay, so just make sure you know, is it a vertex or a zeros problem? Okay, and we're reading, we're trying to understand what's going on. If you're just guessing, that's not going to be good. All right, let's look at number 6. The height in meters of a model rocket on a particular launch can be modeled by the equation h of t equals negative 4.9 t squared plus 102t plus 100, where t is the time in seconds after the engine burns out 100 meters above the ground. When will the rocket reach 600 meters? So my question for you, is this a vertex problem or a zeros problem? It's not asking when does it reach a maximum height. It's asking when does it reach a certain height, a specific height. So this is a zeros problem. Now, we're going to have to change and put 600 in for h of t. It won't equal 0 right off the bat. Okay? So let's look at negative 4.9 t squared plus 102t plus 100 equals 600. I have to make this equal 0. So what are we going to do? We're going to subtract 600 from both sides. So that means I've got negative 4.9 t squared plus 102t minus 500 equaling 0. And now, because this is a zeros problem, I'm going to run the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so our b is 102. So I've got negative 102 plus or minus the square root of 102 squared minus 4 times negative 4.9 times negative 500. Bring that square root all the way down, all over 2 times negative 4.9. I know now, this time it's negative 9.8. For some reason, my brain wasn't clicking in that first problem, or that diver problem. All right, so I'm going to do the square root of 102 squared minus 4 times negative 4.9 times negative 500. And I get negative 102 plus or minus I already took the square root, so this is 24.58 all over negative 9.8. Okay, so I just shoved that radical in the calculator. Now, we are going to think about the top, that negative 102 plus 24.58 is going to give me a negative value. I'm also going to get a negative value when I subtract, so I need to look at both. So when will the rocket reach 600 meters? It looks like it might be happening twice. So here's my rocket, and remember it's going to come back down, and let's say like here 600 meters, it's going to reach 2 places, and so both of them are going to be an answer. Okay, so let's look at, I've got my calculator here, we're going to look at negative 102 plus 24.58 all over negative 9.8. Then we're going to do the same thing but with the minus all over negative 9.8, and we're going to get 2 answers that I feel will probably be valid. So let's see, negative 102 plus 24.58 divided by negative 9.8, and I get 7.9, and this is in seconds. And then negative 102 minus 24.58, enter, divide by negative 9.8, 12.92, 12.9 works as well, seconds. So in this one, there's two answers because the rocket is like, the engine burns out like down here somewhere. Okay, but it's still got enough momentum to keep going. I don't know what highest point it hits. It might not go up too much higher, but it does at some point turn around and come back down and hit 600 meters again. Now let's talk about what happens if we're given a height. We want to know when it reaches 800 meters. Okay, what happens if it never gets there, right? Let's say that this is 700 and we want to know when it reaches 800. Well, it's never going to get there. So what is that answer going to look like? So if that is the situation, then when I look at this piece underneath the radical, we're going to get a negative number. And when I go to take the square root of a negative number, can you handle that? Square root of a negative number? We can't handle that yet, right? So when we get something square root of a negative number, we have to say no real solution. That means that it's never going to reach. Okay, and so that's one of the nice things about the imaginary number system is that it gives you an idea of knowing, hey, there's no way for this to happen. Because otherwise, we're going to have numbers given to us, and we would have to be able to know when will it happen and when will it not happen. And that imaginary number system that pops up allows you to know right off the bat, hey, there's no way that this is happening. So if you end up with a negative number underneath the square root, the first thing I would caution you, make sure that that is truly the number that is supposed to be there. And then if that is not, if that's supposed to be the number that's there, then that means that whatever event they're asking you about is not going to happen. Okay, so you can get two answers. It can hit two places. Okay, now they might change the question. When will the rocket reach 600 meters coming down? But that's not what it says here. It just says when will it reach 600 meters. All right, a pumpkin is launched into the air with an upward velocity of 32 feet per second from the top of a building. Its height, h, in feet after t seconds is given by the function h of t equals negative 16t squared plus 32t plus 192. How long will it take the pumpkin to reach its maximum height? How high does the pumpkin go? So I'm going to have you answer, is this a vertex or a zeros problem? This is a vertex problem because the key words are maximum height. And how high does it go? So how do you find a vertex? X equals negative b over 2a. So our b value is 32, so negative 32 over 2 times negative 16. Well, that's negative 32 over negative 32. That is 1 second. In 1 second, the pumpkin will reach its maximum height. Man, that's a fast pumpkin. All right, how high does it go? Well, let's plug it in. Negative 16 times 1 squared plus 32 times 1 plus 192. So that's whatever negative 16 plus 32 plus 192 is. So let's do negative 16 plus 32 plus 192 is 208. Oops, 208. Is 208 feet. That's how high the pumpkin goes. They have pumpkin launching contests too. It's pretty cool. All right, so make sure you are trying to figure out, is it a vertex or a zeros problem? Okay, because that's the main component of this. I know you know how to run the quadratic formula. I know you know how to find a vertex. I need you to know when it is appropriate to do each one. The height of an object dropped by a plane at 1,600 feet is given by the equation h of t equals negative 16t squared plus 1,600. Now, notice that there's no t value. There's a t squared, there's a constant, there's no t. where t is time in seconds after the object was dropped. How long will it take for the object to hit the ground? So, question, is it a vertex or a zeros problem? Hitting the ground is a zeros problem. Now, there's actually a different way to do this than the quadratic formula. But if you like the quadratic formula, do the quadratic formula. Let's look at this. Negative 16t squared plus 1600 equals 0. So if you're like all about the quadratic formula, run it. B is 0. Okay? However, I taught you how to do this a little while ago where you can solve for t, just like you're solving an equation. Remember subtracting 1600? Negative 1600 t squared equals negative 16 t squared. Let me rewrite that. Negative 16 t squared equals negative 1600. Divide by negative 16. T squared equals 100. Take the square root of both sides, because that's how you make a square go away, and you get t equals plus or minus 10. Which one do you think we're keeping? We're keeping the positives, so t equals 10 seconds. So it's a different way to do it. It's something that I have taught you, but the quadratic formula will work too. Let's look at it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b is just 0. Plus or minus the square root is 0. Minus 4 times negative 16 times 1600 all over 2 times negative 16. All right, so we're going to pop the square root of 0 minus 4 times negative 16 times 1600 in the calculator. And we're going to get 0. We don't really need that 0. We get plus or minus 320 over negative 32. And then a positive 30 or 320 divided by negative 32 is a negative 10. And a negative 320 divided by negative 32 is a positive 10. We throw out the negative, we keep the positive 10 seconds. So there are multiple ways to do this. It's kind of what do you see, what do you notice kind of thing, or do you just really like the quadratic formula? But when all three of them are there, the A, the B, and the C, you probably would be best off doing the quadratic formula. A basketball shot towards a hoop is modeled by the equation negative 4.9t squared plus 20t plus 5, where t is time in seconds after the basketball left the player's hand. When will the ball reach the hoop 12 feet above the ground? Is it a vertex problem or a zeros problem? This is a zeros problem. They want a specific height, 12 feet above the ground. So let's plug it in. Negative 4.9 t squared plus 20t plus 5, and we want it to know when it equals 12. Now, I can't run the quadratic formula like that because it has to equal 0, so let's subtract 12. And this is, of course, the player threw the ball. When it will get to the hoop, we're going to assume that it goes in, right? Okay, so let's plug in, let's get the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so negative b, negative 20 plus or minus the square root of 20 squared minus 4 times negative 4.9 times negative 7 all over 2 times negative 4.9. All right, let's plug in our square root of 20 squared minus 4 times negative 4.9 times negative 7. And I get negative 20 plus or minus 16.21 all over negative 9.8. 8. And then looks like both ways, the negative 20 plus the 16 and the negative 20 minus the 16 are going to give me both negatives. So I'm going to get 2 positive answers, but I don't think, so let's think about what's going on. We have, here's our court, here's our ball player. He's throwing the ball up, and let's say the hoop's here. Don't you love my artwork? Okay, and so it's here. When does it hit that or reach that height? But it was probably that height somewhere else as well. So we want the one that is happening later. That's what we want, the one happening later. So if I do negative 20 plus 16.21 divided by negative 9.8, 0.39 seconds, and then negative 20 minus 16.21 divided by negative 9.8, 3.7 seconds. Remember, we want the one that's longer because it's going to go up, but then it's going to come back down. So we're going to keep the 3.7 seconds. All right, let's do another one. All right, so this is a little bit different, but it's still, it's a graph, and we're going to try to figure out what's going on with this. This graph depicts the trajectory of a ball being launched from the top of a 128-foot building. The t-axis, so it's not x, it's labeled t, if you see there, is measured in seconds. So what is the domain of this function? So I've been trying to ingrain in your brain a quadratic has a domain of negative infinity to positive infinity. However, this is a real-world situation. Can a ball that is being launched from the top of a building go and go and go and go and go and go forever and ever and ever till time ends? No, it's going to hit the ball. The ball's going to hit the ground and it's going to stop, right? So we are going to have some confines on this. We are not going to go to negative territory. We are not going to go into negative time. We're not going to go. It is possible for the ball, like I throw the ball up, it is possible that maybe at some point in time it could drill a hole into the ground. But I doubt it's going to go all the way through the Earth and then leave the other side of the planet and keep going into space forever. I find that hard to believe. It could make a dent in the ground, though. Okay, so we're not going to go into negative territory as far as, it's not going to go to negative infinity. It's not going to go into the negatives at all, either in the x or in the y. So what is the domain of this function? How far left does this function go? The furthest left it goes is 0. How far right does this function go? See here it stops at 4. So the domain is trapped. Yes, most of our quadratics with their abstract properties and all of that, the algebra, go from negative infinity to positive infinity. But if I ask you what is the ball doing at 10 seconds or, 365 days later, it's still on the ground unless the story has changed and somebody's picked it up and done something with it. Okay, so the ball is not traveling through the air anymore. Now what is the range? What's the lowest point that this ball is going to reach, assuming it's not burrowing a hole to the center of the Earth? The lowest it's going to reach is 0. And then what's the highest it's going to reach? Here's its vertex. They tell you it's at 144. Okay, so you are trapped in these real world concepts of, well, we haven't thrown the ball yet. How can it go into negative time? It's not going to go below the ground. It's a baseball. It's not doing that. It's not going to go below the ground. Okay, so we have it trapped. And if you look, that quadratic looks trapped by the x and the y axis. Okay, so that's the domain and the range. Be very careful. Are you talking about the domain of regular quadratic or of one that is of a real world problem? What does the point 0, 128 represent in the context of the situation? So that is the vertex, right? Remember, they're talking about time and height. So time is 0. We're getting ready to click our stopwatch to start the time. What does that mean? This is the starting height of the ball at 0 seconds. It's at 128 feet above the ground. That is where the ball starts. What does the point 1, 144 represent? Well, that's the vertex, right? That's the highest point. So at 1 second, the ball is at 144 feet. But this is the maximum height. The ball doesn't go any higher. The ball doesn't drop down and then change its mind and then go back up even higher than 144. No, it goes up, it hits its high point of 144, and then it comes back down. What does the point 2, 128 mean in this situation? Well, 2 is time, right? 2 is seconds. So at 2 seconds, the ball is 128 feet above the ground. It is at the same height that it started at. You do have that symmetry. But that's probably the last point of symmetry that they've got, because it doesn't go any further on the left. It's going to go to the right. What do you think about 380? At 3 seconds, it is 80 feet above the ground. So this path that we're seeing as a quadratic is, what is the ball doing at specific points in time? So what does the point 4, 0 represent? At 4 seconds, it is on the ground. That's the time that the ball hits the ground. That's a 0. Okay? So, trajectory. We're throwing things up, they're coming down. Now, you're not necessarily throwing things. I think there's a homework problem maybe that might be about some business costs you're trying to minimize. I don't know if I threw that in there or not. But if so, you want a minimum, you're looking for a vertex. So that's the big thing. Can you determine, is it a vertex problem? Is it a zeros problem? For the vertex problem, you find the vertex. For the zeros problem, you figure out where it hits the ground by, you can run the quadratic formula. You can factor, you can take square roots, but use that very, very conservatively, because not everything can be factored. Not everything can be solved by taking square roots, but everything can be run through the quadratic formula. All right, have a wonderful day. We do have a test coming up on Wednesday. This will be on the test. Even that there was that basketball problem, there is going to be one of those basketball problems on your test. So get ready, make sure you're practicing, make sure you're looking over your notes from your, that I leave you from doing your homework and that kind of stuff. Make sure you were studying and getting ready. Make sure if you missed any videos, you're going back and watching them. Maybe you need to watch something again. Maybe you need to email me a question. You got lots and lots of things that you can do to make sure you're ready for this test. But this is the biggest unit we have. It's got a lot of stuff on it. Make sure you're ready. All right, bye, guys. See you in the next video.